Okay, let's get started. And so we continue chapter 8, time value of money, for the second part of the learning objectives. First, let me share my screen. Okay, so for the second part, so last time, I remember we talked about the present value and future value of a single amount question. And also we talk about the present value and future value of ordinary annuity and annuity due. Okay. So I wanted to let you know the relationship between ordinary annuity and annuity due is that, okay, this is the present value of ordinary annuity. Okay, present value of ordinary annuity times 1 plus the interest rate. Okay, that will be present value of annuity due. Okay, it's annuity due. And if we do future value of ordinary annuity, future value of ordinary annuity, okay, times 1 plus the interest rate, that will equal to future value of annuity due. Okay, so let's say you see the present value of annuity due. Okay, present value of annuity due. If the interest rate is 8%, okay, present value of annuity due. This is annuity due, and the present value of annuity. So let's see the present value of annuity. Present value of annuity due, present value of ordinary annuity. Okay, this is the present value of ordinary annuity. Okay, so this is the present value of ordinary annuity. And then you times 1 plus 8%. Okay, that will equal to the present value of annuity due. Okay, the same, you wanted to test that at the same, okay. The question is that we got the present value or future value, we can use the time value of money table, right? But for annuity due, you cannot get to the number directly from the time value of the money table. But we can use the value we got from the table times 1 plus 8%. And then you can get the future value or present value of annuity due. Okay. Okay. Any questions?
Yes, please. Can you tell the lady to mute her audio? It's distracting. I don't know.
Okay. Yeah. So the case is annoying. Okay. Okay. So any questions about this relationship between present value of ordinary annuity and the present value of annuity due? Any questions? Now we talk about this one, amortized loan. Okay, so amortized loan is kind of a question about when you say you got money for a mortgage. So typically we wanted to know how much money you have to pay monthly for the mortgage. And then the question is that usually typically when you get a mortgage, you know that the first several months, okay, or at the beginning, you have to pay a lot more interest than the principal, right? So as you closer to maturity, so you will pay more principal and less interest. So basically, a lot of people, when you look at your mortgage, so it's kind of complain that more likely the first couple of years, and you didn't pay off quite a lot of your principal, you pay off a lot more interest. So basically the first like several years, your money goes to the interest. So the amortized loan, I will skip this part and I will post a YouTube video. So you will see how to calculate amortized loan. And so another one is called a perpetuity. So the perpetuity is a series of equal payment at equal time intervals that will be received into infinite. So what that means is that the payment will be the same, okay, always the same forever. There is no time limit. So basically, we're using this perpetuity model to price preferred stock. So this is the present value of the preferred stock or perpetuity. So we're considering that a preferred stock, okay, because the preferred stock is a pay fixed amount of dividend. So that's payment, because this is the payment will be fixed and they pay forever and if you hold a preferred stock. Okay, just use the payment or the dividend you received from holding a preferred stock. And this is the required rate of return. So that's the price will be your preferred stock. Okay. And so for example, a share of preferred stock pay a constant dividend, $5 per year. What is the present value if the required rate of return is 8%? So you just use the $5 divided by the 8%, because that's gonna be the price of the preferred stock. Okay, any questions? Okay, next one, we're gonna go over this other different function we have is called yield, or the SOFR K. So let's say you have a 200 investment that has grown to 230 over 2 years. What is the annual return on this investment? Is SOFR K. So sometimes we call the K is interest rate, hurdle rate, required rate of return, or yield. Okay, yield, Y-I-E-L-D. So how you do this? Okay, this question I will introduce you another function we use typically using Excel spreadsheet. So when you open that Excel spreadsheet, okay, so let's say you type the question. Okay, what's the annual return? So in this question, we have $200 investment has grown to 230. So the present value. Okay, make sure, so the present value is your investment. Make it negative 200. Okay, present value is a negative 200. Future value is $230. Okay, so the rate is the one you're gonna solve for. What is the annual return? So how many years? So 2 years, right? 2 years. Okay, the number of time period is 2. Okay, so you don't have any payment during this process. So we choose, okay, the annual return, which is the K is going to solve for. Remember, we have all the parameters. Okay, now the function I wanted to introduce is called rate. Okay, R-A-T-E, rate. Okay, you choose the number of time period 2, and your payment. Okay, no payment. Remember, payment is 0. And the present value is negative 200. And the future value is 230. Okay, so that's the required rate of return or the annual return. So when you click on return, okay, it's going to 7%, or you check group, okay, 7.24%. Okay, remember, so this one you can use the rate function. Okay, when asking you the annual return. Okay, any questions? Okay, so next one we talk about compounding more than once a year. So typically when later on we introduce the bond valuation, we are going to use very often that the semi-annual compounding. Okay, so they compound twice a year. Okay, that's semi-annual compounding. Or you compound 4 times a year is a quarterly compounding. 12 times a year, monthly compounding, or 350 days, you know, that is daily compounding. Okay, daily compounding. And so let's do this question. We're using semi-annual compounding. So see how the result is going to change. Okay, you have 500 investment at 9% annual interest rate for 2 years. So you compute the future value. Okay, so first we have present value, which is a negative 500. Okay, make sure that you have investment and you make it negative 500. Otherwise, you cannot get a solution. The interest rate, okay, is 9%. The number of years, okay, this is 2 years. Okay, so we call this one. Total number of years is 2 years. Okay, so we compute the future value. Okay, this is how you calculate the future value because the present value is 0. So this equal to the future value. Okay, the rate 5% or 9%. Total number of years, payment, and the present value. Okay, we assume that this type of question by default is paid at the end of the year. Unless otherwise they mention something at the beginning of the year, so you're using annuity due. Otherwise, all the payment we assume that was made at the end of the year as by default. Okay. Okay, that's the future value. And Okay, this is annually. Okay, so we, let's say we insert something here. So we call this one is annually. So annually is that the interest you compound only once, right? Okay, so we have semi-annually. Okay, if you compound interest rate for 2 times a year, okay, this is going to be the present value. Okay, the present value is still the same. However, the interest rate, this is annual rate, 9%. And so the 9% will divide by 2 because the half a year every 6 months, the rate will change to this one divided by 2. Okay. This is the total number of years or time period. Okay, this one times 2. Okay. Okay, remember this one divided by 2 and this one times 2. So the number of time period will double because we're gonna say, we say 2n, right? Double the rate, you take half of the rate, okay, divided by 2, make it semi-annually. Present value is the same. Okay, so what is the future value? Equal to future value rate, okay, the total number of time period and the payment, present value. Okay, this is annual component. Okay, when you click on that, okay, you see this is a new feature value. Any questions? Good. Okay. We continue to do that. For example, using the monthly. Okay, we skip that daily or quarterly, but you know we do something with using monthly. Okay. Another one, we see this is a monthly compounding. So what happens is this is still the same. The present value will not change. Okay. The interest rate will be, okay, this rate divided by 12, that's monthly. Okay. And the time period will times 12. Okay. Okay, so you choose the future value. Okay, the rate, the number of time period, and payment to 0. And this is your present value. Okay, the future value will be 598. So we can see that's okay, the rate, okay, divided by 12. If you do monthly, the number of time period is n the times 12. Okay. So as the frequency increases, okay, we can see the future value increases, right? Increases. Okay. There's another one. Okay, I wanted to tell you is continuous compounding. Okay. And so continuous compounding, we're gonna use that. If you take a finance courses, a feature in my international finance or risk management, you will know we're gonna use most of the time using continuous compounding. So the continuous compounding is that the frequency keep increasing. So they're gonna compound at every moment. So at every moment. So it's even more than 365. Okay, so it's a keep continue compounding at every moment. So that in that case, so we have the future value, okay, will be, okay, future value will be the present value times, okay, this is your present value, times exponential mark, okay, exponential raised to the power of rate, okay, times t. Okay, that's a continuous compounding. Okay, continuous compounding is going to even higher. So we do this one is going to be the future value times a exponential. So we know a is exponential. Okay, raised to the power of this k times n. Okay, that's a continuous compounding. Okay, so in the textbook, a is so do you know what a is? 2.718. Okay, this number is similar to the Greek letter. You see like a pi, 3.1415 something. So there's a e in your math class is equal to 2.718. So that's you see if you do this present value times 2.718 raised to the power of this is k times 2. Okay. So, but in Excel, you can use exponential function. Okay. Otherwise, this is pretty close, right? So you can see these two numbers are very close. So that you can do 2.718 or if you do not have a computer, so calculate the value continuous compounding by hand. Okay. Okay, so compounding frequency increases, okay, and the future value will increases, holding that present value, the rate and year constant, right? So you can see how that happens. Okay. Okay, this is the function we called is for continuous compounding. Okay. Continuous compounding. Okay, any questions? Okay, good. So I will teach you something else. Okay, it's not in the slide. It's a very interesting thing is a 72 rule. How many of you know what is a 72 rule? No? Anybody know who is what is a 72 rule or you have ever heard of that?
No.
Okay. So the 72 rule is that, okay, so I have, it's asking you, take how many years you can get your money double. Okay. So this question is like, say, how long will it take for $5,000 to double if it's deposit and earn 6%, 6% per year compound semi-annually, okay? Or compound, let's say 6% per year. Basically, they are the same thing, okay? How many years you can get your money double? 72 rule, okay, is very simple. It's just using 72 divided by the 6%. Okay, we call 72 rule, 12 years. Got it? Okay, so later on when you work in a business, they ask you how many years you can get your money double. Okay, you just use 72 divided by the interest rate. Okay, that's about 72 years. And in Excel, we have another function that's called NPER. NPER is to calculate how many years. Okay, the rate, okay, let's say 6%. Payment, 0. Your present value, negative $5,000. And future value, okay, when the money double, is going to be $10,000, right? Okay, so you can see how many years exactly when you're using the NPER function. Okay, it's 11.895 years. So around like 12 years, right? Okay, or you do the same thing. They ask you, okay, how many years your money can double? They didn't tell you you have to deposit $5,000, whatever. So you just using NPER, how many years your money double? Okay, the rate, let's say 6%. Payment is 0. Okay, present value doesn't matter. You just -1, and then it's double. Future value you choose 2. Okay, if you do -1 and 2, it's still the same result, right? Okay, let me see. Okay, 0, -1, and okay, it's now 60%. It's 6%. See, you got the same. Okay, or you using -100, so you invest $100 and you get $200. This will not change the time, how many years you will get your money double, right? Okay, so when the question asks you how long it takes for to get your money, is going to using the NPER function. Okay, so using 72 divided by 6, okay, that's 72 row, and also you can using the NPER function. Okay, today we learned the rate function, and then also you need to know how to calculate the NPER function, right? And okay, let's see, we have something else. Let's see, uneven cash flow. Okay, this is a very interesting thing. Okay, uneven cash flow. Because the annuity is good. Annuity, you know that you will receive this amount. And so you know you're gonna receive that same amount, okay, for several years. But for some of time, the cash flow you receive is different. So for example, you have you require the return at 6%, and you receive $2,000 for the first year, and then $3,000, and then $4,000, and then $5,000. Okay, for next 4 years, what is the most you're willing to pay for today? Okay, for this investment today. So they ask you the present value of this cash flow you're gonna receive in next 4 years. Okay, this is called uneven cash flow. Okay, how you do that? Okay, so we know the rate. Okay, the rate is 6%. Okay, so this is the rate you have. is 6%. Okay, now we do this one. We're using the function is called net present value. Okay, so you will have the net present value function. Okay, is choose the rate. Okay, 6%, and then you comma, you choose all the values. Okay, choose all those values. And then you close the parentheses. Okay, this is very convenient for you to calculate event cash flow. Okay, when you click on enter, so it's gonna pump out with percentage, so you need to have to, maybe you have to fix it. Okay, the present value, this is 11,875.
What does the rest of that question say?
Okay, so what is the, okay, what is the most, let me cut it this one. What's the most that you wanted to pay for that price, for that cash flow?
Okay.
Okay, what's the most that you would be willing to pay for this investment? So this question is asking you how much money you were willing to pay today, okay, at this moment. Okay, and let's see, I think there might be one more question about the payment. Okay, another question is asking you is going to be the payment function. So we have the net present value function, right? So there another one is called payment. So and so the payment is asking you. So we're using this one as a PMT function. So for example, you have a loan, like you got a loan, and then you have present value, which is you got 200,000 loan. Okay, you will pay in 5 years or 15 years. This is 15 years. Okay, and the interest rate is 5%. Okay, asking you how much money you have to pay every year. Okay, so this is going to be the payment. So asking you how much money you have to pay every year to pay off this money. So it's going to be using payment function. So PMT, so the rate, you have the rate, number of years, number of time period, and then your present value, and then your future value, you pay off, okay? You pay off. So that's how much money you have to pay every year. So it's giving you the payment. So there's another function we used is called payment. Okay, so did you see that you have a project? Okay, the project is similar to the question we talked about today. And so make sure, so what are the question it is asking you, and then what type of function you need to use. Okay, the use basically is ask you to calculate a number of years or payment, right? So you need to figure out that question for the project. And the project is a group project. So only one member from your group to submit, only one, okay? Only one member is required to submit to on behalf of the whole group. Okay, do not submit individually. Okay, questions? Okay, so good. So if you forgot to type your name, please open the chat box and then type your name.
Professor,
Yes.
would you be able to post that Excel sheet on Blackboard?
Okay, I will do that.
Okay, thank you.
Also, the video, I will record this and to post on it's called a webinar. So I will post on Blackboard as well.
Okay, sweet.
Okay, good. Let's stop here. So any questions? Okay. If you don't have any questions, send me an email if you come out with questions. Okay. Okay. See you next Monday around the same time.